तो बच्चों इस वीडियो में हम लोग कंस्ट्रक्टिव और डिस्ट्रक्टिव इंटरफेरेंस पढ़ेंगे। तो कंस्ट्रक्टिव इंटरफेरेंस कब होता है? जब टू इंटरफियरिंग वेव्स हैव ए डिस्प्लेसमेंट इन द सेम डायरेक्शन। तो यहाँ पे एग्जांपल में देख सकते हैं आप, ये दो वेव्स है, एक ब्लू कलर और एक रेड कलर, ठीक है। तो जब इंटरफियर होती है दो वेव्स, तो यहाँ पे आप देख सकते हैं कि ये दोनों वेव्स का डिस्प्लेसमेंट एक ही डायरेक्शन में, ओके, ऊपर के डायरेक्शन में। इसलिए नेट जो डिस्प्लेसमेंट होगा वो भी ऊपर की तरफ है। तो इस तरह की जो इंटरफेरेंस है उसको बोलते हैं कंस्ट्रक्टिव इंटरफेरेंस। और ये दो सेकेंड एग्जांपल है, इसमें भी देख सकते हैं आप, दोनों वेव्स जो है इसका डिस्प्लेसमेंट नेगेटिव वाई डायरेक्शन में है। ऐसी वाली वेव्स जब मिक्स हो जाएंगी तो उसको बोलते हैं कंस्ट्रक्टिव इंटरफेरेंस। और जनरली कंस्ट्रक्टिव इंटरफेरेंस में क्या होता है, एम्पलीट्यूड जो रहता है, नेट एम्पलीट्यूड, दैट इज ग्रेटर देन इंडिविजुअल एम्पलीट्यूड्स ऑफ द वेव्स। अभी देखते हैं कि डिस्ट्रक्टिव इंटरफेरेंस क्या होता है। Now let us look at the destructive interference. In the destructive interference, what happens is that the two interfering waves have a displacement in opposite direction. So for the red wave, the displacement is in the positive y direction. For this blue wave, the displacement is in the negative y direction. So it is opposite to each other. And when such waves interfere with each other, basically their amplitudes cancel out, and the net amplitude will be zero in this case, considering the amplitude of both these waves is same. Even if the amplitudes are not same, what happens is that amplitudes are subtracted from each other. So basically the net amplitude will be A1 minus A2. Now let us see how to find out the max net amplitude and min net amplitude. So max net amplitude is given by A1 plus A2. So you can see that amplitudes are being added to each other, where A1 and A2 are amplitudes of two waves respectively. And this formula is derived from this formula. We know that a net square is equal to a1 square plus a2 square plus 2a1 a2 cos phi, and the range of cos function is between minus 1 and plus 1. So maximum value of that function is plus 1, minimum value is minus 1. So in the constructive interference we will have the maximum amplitude, right? And maximum amplitude is possible when this particular value is 1, cos phi value is 1. So basically we get this one, a net square is equal to a1 square plus a2 square plus 2a1 a2, which comes out to be a1 plus a2 square, and that is why a net max is equal to a1 plus a2. That's the maximum value because we have put cos phi as plus 1. In the destructive interference we will have the minimum amplitude value because the amplitudes cancel out with each other. And if you put cos phi as minus 1 in this equation, what we get is a1 minus a2, net amplitude minimum. Same way, the net intensity in the constructive interference is root I1 plus root I2 square, and this is also derived from this equation. So you need to know these two equations. I net is equal to I1 plus I2 plus 2 under root of I1 I2 cos phi. And what we are doing is just that cos phi's value is being put as plus 1 or minus 1. When you put plus 1, it is basically giving us the maximum intensity. When we are putting minus 1, it is giving the minimum intensity. So I net max is under root of I1 plus under root of I2 bracket square, and net intensity minimum value is under root of I1 minus under root of I2 bracket square. And the constructive in the constructive interference, this I net max or A net max, these values are achieved when the phi is 0, 2 pi, 2n pi, or delta x is 0, lambda, 2 lambda, n lambda. So basically when it is even multiple of lambda by 2, delta x is even multiple of lambda by 2. In the destructive interference, these minimum values of amplitude and intensity are possible when the phi, the phase difference, is pi, 3 pi, 5 pi, 2n plus 1 pi. So basically odd multiples of pi and odd multiples of lambda by 2. That's it. Thanks for watching.